Okay, today we will look at real power control. So as I said previously, our class we talk about operation, we talk about the economic dispatch. Okay, so for power system control, we will look at real power control, or sometimes we call it frequency control. And then we look at the reactive power control, or sometimes we call it voltage control. Okay. See. So this is two part left for this class. So we have learned about the economic dispatch. We learn about all the techniques. So power control, we look at how we want to control the real power. Because real and reactive power we can control separately. The power system control deals with the control of active and reactive power. So to keep the system in steady state, meaning that there is no fault happen. Okay. So the objective of the control strategy is to generate and deliver power to interconnected system as economical and reliable as possible while maintaining the voltage and frequency. So basically we want to maintain our voltage and frequency within the permissible limits. Okay, so changes in real power will affect mainly to system frequency. That's why when we talk about the real power control, normally it will related to the frequency. So berapa frekuensi Malaysia ni? Kita pakai berapa? Tak ada orang lah. Tak ada orang ni. 45 orang ni. Malaysia berapa frekuensi kita?
230.
Itu voltage. Frekuensi?
50.
50 Hz. Okay. Why reactive power is less sensitive? Kalau you belajar, bila kita buat, you belajar dekat load flow analysis, ingat tak? You belajar interaction dan you belajar fast decouple kan? Dua benda tu kalau you belajar, basically fast decouple tu dia from the interaction, and you can see that when we learn that some of the components when you do the Jacobian kan, so some of them you assume kosong. So normally when we do the voltage, it will be less sensitive to the real power changes. So that's why reactive power ni dia lebih kepada effect pada voltage kan. So kalau you ingat you belajar dekat EPS pun untuk power factor correction, normally we play around with the reactive power in order to increase the power factor kan. So we reflect to the SP dan juga ni lah. So that's why reactive power ni dia less sensitive to the changes of frequency, but dia depend on the voltage magnitude. That's why kita boleh control real dengan reactive ni separately lah. So sebenarnya dia bukanlah tak ada effect, the effect is very minimal. So that's why in this class, kita akan cerita pasal real power control dengan reactive power control ni separately. Nama lain active power control kita panggil load frequency control lah, sama. Okay, so sebab active power ataupun real power reflects to the frequency, so sometimes the term is, we call it load frequency control. Okay, because it control the real power and frequency. So automatic voltage regulator loop regulate the reactive power and voltage. So untuk reactive and voltage biasa kita pakai AVR. Okay. And then LFC and AVR installed for each generator and interconnected power system as shown in figure. Yeah. So kita ada AVR. Kat sini dia ada voltage sensor. They control the saturation system. And then for the loop frequency control, we have sensor for the frequency. So we have sensor for the frequency. Kalau ada perubahan, it will control the load in order to sama dia open ataupun close the valve ni lah. Okay, turbine as well as what. So this one is the schematic diagram. Simple when we have a low frequency control installed in the synchronous generator. So kita ada low frequency control, kita ada AVR. Okay, LFC gain in importance with the growth of the interconnected system because today, nowadays, we have very complex power system. Okay, yang mana kita panggil dia interconnected lah. It is interconnected. Kalau sebelum-sebelum ni, it's just very direct. So sending and receiving. So now we have very interconnected system from the generator. Okay, you have generators. And then you have, normally you have transformer, right? So you have generator, normally it's low voltage. You have transformer to step up, let's say 11 to 32 kV. And then you have, sometimes you have another transformer to step up into the higher level, higher voltage when you have transmission, long transmission line until 500 kV. And then you step down balik dengan transformer untuk dekat distribution kan. So until distribution level lah, sama ada you ada distribution within the radial system, okay, ni load system lah, ataupun ada ring system, ada banyak. So that is the system, but it's very complex, not only from the sending to receiving, but also you ada interconnected system. And since power system ni is very interconnected, sometimes you can transfer the power to other countries lah. So dekat utara kita ada IGAT kan, kita ada IGAT Thailand. So IGAT NTMB, dia ada mutual perjanjian lah. And then kita ada juga dengan Singapore. Sabah Sarawak kita ada SSB dengan Sesco. Even though TMB ada share lah dalam tu. So itu is very very complex. Okay. One of the basic requirement for the successful operation of system in the system frequency must be maintained. So kita cuba maintain kita punya frequency 50 Hz. Because when we have a load variations, so bila ada load variation, so generator akan try to fulfill the demand. Okay, and then when that happen, so the frequency ni akan oscillate. Okay, but we must make sure that our frequency maintain at 50 Hz. Dia kena maintain kat 50. Baru nak masuk ni. Okay, 50 Hz. Dia ada dia punya ratio apa, dia punya limit lah, plus minus berapa, I think 0.5 Hz max. Maknanya you boleh oscillate between 49.5 until 50.5 lah, max. Okay. And then normally when we say about the system in the under steady state conditions, the total real power generation normally equal to the demand and real power. Ni yang kita belajar dekat economic dispatch, mana you punya PGI must be equals to P demand plus P loss kan, equality constraints. So under steady state, normally the real total power generated ni must be equals to demand plus loss. Okay, so any difference, kalau ada berlaku perubahan, it is immediately changed in speed or frequency at the generation level. Okay, so that's why when we say about lead frequency, maknanya kita akan, instead of kita tengok pada system overall, basically kita akan tengok pada sistem generator tu sendiri. So what happened into the rotor, the frequency, speed dan sebagainya. So normally generators are fitted with speed governors. So we have speed governors that will have varying characteristics. So different sensitivities, dead bands, response time and groups. So ni kita akan tengok nantilah. So the characteristic of the generator is varying. So that's why we need to learn how we want to, when the load changes happen, what happened in the generators. Okay, so in terms of the frequency and speed. Okay, they adjust the input to match the demand. Normally we will the generator will always try to match the demand, but within their limits. Okay, any change in the local demand within permissible limit is absorbed by the generators in the system in random fashion, And independent aim of the automatic generation control is to reschedule. So reschedule the generation changes to the pre-select machines in the system after governor have accommodate the load change. So when the load happen, when the load changes, sama ada load bertambah ataupun berkurang, so governor akan accommodate the load change lah. Let's say we have the several generators, so the ataupun machines, so governor akan accommodate the load change in a random manner. Thus, the additional supplementary regulating device are needed. So basically, when we have the system, we have also the auxiliary and so on and so forth. So macam ni lah. So this is the block diagram, load frequency control. And then this one is, we call it tie lines. Tie line ni contoh macam TMB and IGAT tu lah. So TMB and IGAT Singapore, so kita ada tie lines connected. So let's say we have in the system, in the overall system, you have load, PL is load, it must be equal to the PGI. So let's say we have several generators. So and then when the load changes happen, all the generators will be sensed. Jadi several, bila ada perubahan akan ada data P kan, bila ada data P, so governor akan select, adopt ataupun accommodate the load in random manner lah. So yang ni akan random lah, maknanya siapa yang akan berubah tu lah. Okay, we have turbo generator 1, generator 2 until generator N. So the sensor will pick up the difference whether to increase or decrease. Kalau load to decrease, when your load is suddenly decrease, maknanya bila load decrease, suddenly your generator akan jadi lagi laju lah. Kan, bila jadi, so dia akan control to make sure that it's always in the equilibrium. Okay, sama juga kalau load increase. Bila load increase, suddenly your generator akan jadi slow kan, but nak meet the demand. So and then you need to open the valve in order to put more power input to control, to get the output, desired output. So always try to maintain the equilibrium condition. Okay, this one yang saya cakap tadi lah. Consider small step increase in load. Ni increase lah. Increase. Bila increase, the initial distribution load increment is determined by the system impedance and the external relative generator rotor positions. The energy required to supply the load increment is drawn from the kinetic energy. Yang ni you relate with the mechanical punya knowledge, with the energy of the rotating machines. As the result, the system frequency drops. Sebab apa? Bila load increase, generator akan jadi slow sikit, so your frequency will be dropped, your F will drop. And then the distribution of load during this period among the various machines is determined by the inertia of the rotors and the generator partaking in the process. Okay. After the speed of frequency fall due to reduction in stored energy, the rotors has taken place. The drop is sensed by the governors and they divide the load increment between the machines as determined by the groups of the respective governor. And then secondary control restore the system frequency. So maknanya dia kena the sense the changes. So what we need to do, we control the open balik you punya valve in order to increase the input, in order to make sure that your power supply by the generators always meet the demand. Okay, meanwhile the automatic generation control AGC is the scheme that responds to adjust the generation automatically. So basically ni the modern control system kita ada AGC. Okay, so basically yang ni dia akan automatically lah. So each generator provide allocated shares and system frequency is always maintained as close to nominal value 50 Hz. Okay, and then the exact contract megawatt flows through the tie line between the two system. Ni kita akan tengok nanti in details tie line block. Okay, tie line topic. So this is the generation process for the power demand. So that's why for the initial step, we start with the flow forecasting. Maknanya TMB ataupun we have in Malaysia an LDC, National Load Dispatch Center, the forecast what happened in the country. So how many loads will be used ataupun will be utilised. So normally based on the season lah, kan. Bila musim hujan, sejuk, so mungkin load tu kurang ataupun kurang lah. Bila musim panas, so bila kita ramai sangat guna aircon, so load will be increased dramatically ya. So what you boleh buat, dia forecast the load. That's why load forecast ni in power system is one of the research that still going on until today ya. Load forecast. Biasa load forecast ni kita guna machine learning. Ni saya cakap in terms of academic lah. And then when we do the load forecasting, you start belajar daripada kita punya, yang kita belajar dalam kelas ni, kita start dengan economic dispatch. Sebenarnya sebelum economic dispatch, ada satu area juga, yang ni pun another research. We call it unit commitment. Unit commitment ni maksud dia ialah analysis decide yang manakah generator yang akan operated. Kan? So dia akan decide, katalah kita ada 100 generator, so load katalah berapa gigawatt. So dia akan decide sepatutnya dalam skala katalah 10 gigawatt hanya ada, kita ada 100 generator, mungkin dalam 50% dia yang operated. So 50% tu dia decide based on the studies, we call it unit commitment. Dia sama juga, unit commitment studies ni dia akan cuba dapatkan the minimum cost lah. Mana generator yang dapat minimum cost operated. Sama dengan unit economic dispatch. Economic dispatch ni kita dah tentukan kan, katalah kita dah tentukan 4 generator untuk supply berapa megawatt. Okay, unit commitment ni sebenarnya kita ada 10 generator. So kita decide 4 saja yang operated. So ini adalah satu studies lah, this is another studies. But before that, you need to learn about load forecasting. How we want to forecast the load. Biasanya load ni dalam bentuk periodical lah. Dia ada short term. So load forecast ni dia ada, kita tanya load kan, dalam setahun. Kalau tahunan kita panggil long term lah, long term load forecasting. And then dia ada medium term. Medium term mungkin dalam bulan. And then dia ada short term. Short term ni yang biasa dia agak berubah, agak varies lah. Dia akan very fragile lah data. Short term forecasting ni biasa dalam hours lah, hours to days. And then ada very short term. Ni second. So biasanya yang glamour ialah short term load forecasting. Ni studies yang have been done not only by TMB by banyak lagi lah. Okay, for those yang tahun akhir, kalau you prefer, you berminat nak study dalam load forecasting ni, you boleh ambil master lah. Kita ada master by course. Saya ajar subjek dekat master by course. Okay, tajuk yang saya ajar tu AI application in power system. Okay. So basically we learn about the load forecasting. And then kalau you dah ambil kelas saya, sepatutnya tak ada masalah sebab just repeat balik economic dispatch, tapi guna yang saya tunjuk itulah meta heuristic ataupun nature inspired. And then another thing is belajar tentang DJ allocation. Sebab need to relate with the renewable energy kan, sebab you punya master dekat fakulti elektrik ialah Master of Ethical Sustainable Energy. Okay, subjek saya ini bukannya subjek core, subjek elektif. Kalau you berminat, boleh study lah. Boleh further study. Okay, so this one is the what we learn previous, yang ni lah kita belajar. So now we look at into the generator tu sendiri ya. So decide the governance setting, change setting, and then what the AGC, and then decide actual system frequency, and so on so forth. So and then we have a SCADA. SCADA tak belajar kat sini lagi, belajar kat subjek lain. So this one in terms of dekat power station, this one dekat control area lah. Okay. So this is generation flow process for the power demand as a general. Boleh setakat ni, baru nak masuk ni. Kalau nak habis dah. Okey boleh lah setakat ni kelas. Sekejap ramai.
Boleh, Doktor.
Boleh, Doktor.
Okey. Okay, this is the overview of the power generation. So you have turbine generators, and then normally in the power system, we have varies. Load ni sebenarnya varies kan. Dia bukannya static, bukannya okay kita nak 5 megawatt jadi static, dia 49 and then varies naik ke dalam. So dia varies every second. Okay, so there is a frequency measurement, or we have a frequency transducer or sensor, dia akan measure balik. Dan dalam power system control, kita try to maintain, for active power control, try to maintain your frequency as close to 50 Hz lah. So dia akan varies frequency ni. Bila dia load berubah, bila load naik, your frequency akan turun. So dia akan open the system, open the valve to make sure that power the input is increased in order to meet with the demand. And then when suddenly the load drop, your frequency become jadi laju kan. Dia macam naik basikal. Tiba-tiba you ada brake apa ni. Bila brake tu maknanya ada beban. So tiba-tiba akan jadi slow. Kan? And then bila you naik basikal and then tiba-tiba turun bukit, beban tak ada. Kurang. So dia akan jadi laju lah. So how you control to maintain your speed, ataupun kat sini kita tengok kita punya frekuensi je. So the analogy is simple. Similar lah. And then we have generation control. So kalau ada, since kita punya system is interconnected, not only within the countries, but also with the other countries, we have a agreement, okay, PPA and so on and so forth lah. Kita ada agreement dengan Singapore, we have agreement with IGAT and so on and so forth. So macam mana kita nak study to make sure that the tie line in the neighboring system lah. So this one is tie line ataupun time flow neighboring system. Okay, so let's take a look yang saya cakap tadi, ulang-ulang banyak tadi. So bendanya ialah dependence between real power. That's why we learn about the real power control and the frequency control is similar. So let's say we have ni kita assume tak ada loss lah. Maknanya simple analogy lah. Generation fulfill the load. Okay, so generation fulfill the load. Let's say you ada load 50 megawatts. Total generation akan dapat 50 megawatt juga. So yang ini biasanya pada steady state condition, kita punya frekuensi at the nominal frequency. And then suddenly your load jadi kurang. Kan, bila berkurang maknanya generation ni lebih. Okay, and then bila generation lebih jadi laju, so maknanya your frequency now is your frequency nominal plus delta F. Okay, and then suddenly your load is increased, maknanya generation is kurang daripada load demand. So apa yang berlaku, your frequency akan drop. Okay, frequency akan drop. That's why you get frequency equals to F0 minus F theta F. So ni yang kita akan tengok macam mana kita control apa yang berlaku bila kita berlaku ni. Kita akan dalam sistem akan berlaku synchronous kita punya governor akan bekerja macam mana dan juga kita punya generator. Okay, usually typical value dPL over dt, maknanya load with respect to time lebih kurang 2 megawatts per minute per 1000 megawatts in early hours. Maksud dia sebelum pukul 7 lah. Tapi bila peak hours 7-8 buat orang sibuk nak pergi kerja, yang ni 7-8 malam bila orang balik kerja kan. So your load changes ni akan jadi lagi banyak lah. Sometimes dia dapat 8 megawatts per minute per 1000 megawatts peak. Okay, so ni what happen when we have a very load in the system. Sebab kalau dalam economy dispatch yang kita belajar sebelum ni, kita belajar tentang at the static. Dia bukannya dynamic. Static lah. That's why there is a research on buat dynamic economy dispatch. So static ni maksudnya pada at particular hours. Setelah pukul 6, 50 megawatts. So berapa economy dispatch cost yang dapat kita minimumkan. And then tiba-tiba you load demand is changes to 7 AM ni jadi ke 100 megawatts. So apa yang berlaku dalam, kita buat satu-satulah economy dispatch untuk dapatkan cost minimization. But yang ini kita akan tengok, kita control how we want to control when we load open or load increase, what happen in the system. Okay, to cope with this and maintain the frequency at the nominal value, biasa kita akan refer to 50 Hz because our country's system is 50 Hz. okay, within the prescribed range. So biasanya plus minus 0.5 Hz. Meaning that your frequency boleh beroperasi daripada 49.5 hingga 50.5 Hz. Okay, dia tak boleh bawah lagi. The power engineer constantly monitor the frequency. Sekarang dulu kena constantly monitor lah. Sekarang ni everything is computerized, so dia monitor kat komputer lah. Power engineers constantly monitor the frequency and adjust the output of one of the more generating units through the governor control. So ni yang dia akan control either in manual mode or in a fully computer control automation mode. So basically kita akan pakai automation lah. Okay, or large system interconnecting two or more more areas having a number of generators in each area. So modern gas turbine have an overload capability for a few minutes. So biasanya dalam modern power system, power generator ni kita ada overload capability untuk for few minutes. Tapi dia tak boleh lama. Kalau lama dia akan the lifespan of the equipment akan drop lah. Dia akan kacau. Okay. Normally for the emergency situations, if data is small, is no noticeable effects on the most consumer. Biasanya frekuensinya kita tak akan rasa sangat lah. Tapi bila heavy, you boleh rasa lah. Biasanya bila berlaku macam kalau di overseas berlaku gempa bumi dan sebagainya lah. Natural disasters dan sebagainya. Okay. However, the speed and accuracy of synchronous electric clocks are affected. Okay, so biasanya dia akan kacau pada electric clocks. Ni untuk equipment yang ada ni lah. So dia akan kacau plus minus berapa second, millisecond. Okay. On the other hand, if the data f 0.5 Hz and persists for a long time, steam turbine blade sometimes resonates, leading to metal fatigue. So dia boleh menyebabkan you punya sistem, you punya generator akan fail. So itu kelemahan dia lah. Maknanya itu kita cuba elakkan kita punya frekuensi ni drop dekat 49.5 terlalu lama ataupun overload kat 50.5 Hz terlalu lama. Okay. Biasanya this is the maximum yang boleh sustain 9 minit je lah. So it will resonate leading to metal fatigue. So metal fatigue ni maksudnya you punya equipment akan boleh rosak. Okay, the speed and output of fans and pump depend on the supply frequency. If data F more than 1 Hz, the reduced speed of fan and pumps in power auxiliaries reduce station output, which may sometimes lead to serious situation like cascaded outage or blackout. Kita panggil apa? Kita panggil blackout kan? Cascaded. Di OC, di UK, US panggil outage. Maknanya tak ada current, kalau kita panggil tak ada current lah. Itu yang pernah berlaku dekat Malaysia pada tahun 96. You all ada belum 96? Yang blackout satu Malaysia. Okay, and then pada tahun 96 saya masa tu form 4 kat sekolah asrama, blackout. And then lama juga rasa dalam malam start blackout, maghrib atau pagi. And then 2003 saya dekat Panasonic, saya kerja kilang tu. Tapi petang lah, dalam waktu petang pukul 2 sampai pukul 3 waktu 4. Yang itu KL saja, KL ke Johor. Sebenarnya zon selatan saja. Okay, so that one from I think the transformer blow. There is a report from the TMB lah. Okay, and then also there is a rumors about the event. Never mind. Okay, we look at turbine generator characteristic and then kita stop lah. Yang ni kita akan tengok hari Khamis ni. When the generator electrical load is suddenly increased, ni apa yang saya cakap tadi lah, diulang balik. Benda yang sama je. When generator electric load suddenly increase, the electrical power exceeds. Macam tadi kan. Sebab power electric is based on the electrical and mechanical output. Okay, so when we have the electrical load is increased, naik, the electrical power exceed the mechanical power. Okay, PE exceed mechanical power, PM. This power deficiency is supplied by the kinetic energy stored in the rotating system. The reduction in energy cause the turbine speed and consequently the generator frequency to fall. So bila macam tadi lah, when your electrical load is up, your frequency will down. Okay, the change in speed is sensed by the turbine governor, which acts as the and to adjust the turbine input valve to change the mechanical power output. So dia akan open the valve to make sure that there is more input to increase the mechanical output to make sure that your PE and PM at the steady state lah. So the earliest governor were the watts governor ni. Kalau dulu-dulu nama dia watt governors. Okay, which sense the speed by the means of rotating fly balls. Dalam gambar ni lah. Ni adalah speed governing system. Kita guna watt governors. Okay. However, most modern governor use electronics. Biasa sekarang kita guna electronics, so very sensitive. Kalau berlaku perubahan tu dia akan very sensitive. So figure 4 shows schematically the essential element of conventional watt governors. Okay, so we have speed governor here. So the speed changer. This one we have a hydraulic amplifier, and then to control the governor valve to open or close lah macam tadi ya. So ensure to add, to increase. Kalau berlaku load increase, your mechanical will become low, and then you open the valve to make sure the input more input to make sure that maintain the speed. Okay, so this is the major parts. The part is speed governor, which is speed governor. Gambar ni lah secara mechanically. Okay, this is the essential part. Centrifugal fly balls driven direct to the gearing by the turbine shaft. Okay, you boleh tengok details dalam kat YouTube, ada banyak video post pasal ni. And then we have a linkage mechanism. This link for transforming the fly balls, and then we have, ni boleh baca sendiri kot, and hydraulic amplifier. Okay, to open or to close the system. And we have speed changer. Speed changer consists of the servo motor which can operate manually or automatically for scheduling load at nominal frequency. Normally kita kan nowadays everything is automatic, so you just set up je. And then by adjusting this point set, a desired load dispatch can be scheduled at nominal frequency. So this is speed changer. Okay, speed changer. To lower, to raise. Okay, so this is what we call it speed versus power output. Okay, this figure kita akan guna banyak dalam analisis load, terutamanya bila load division antara generators lah. Kita akan tengok dalam next class lah. Ini. Okay, so figure 5 show the governor characteristics for the large turbine, large steam turbo alternator. There is 4% drop, atau nama dia 4% drop atau droop lah, in speed between no load to full load. So this is y-axis is speed in per unit. Okay, kalau 4% maknanya 1.04 kan, betul kan 4%. Kalau 1.4 is 40%, so 1.04 is 4%. And then dekat as your power output, this is the full load. The power output in terms of per unit lah. This is x-axis power output, y-axis your speed. Kalau you ingat masa kita belajar dekat economy dispatch, the analysis is what? This one is cost kan? This one is power output. So the function is quadratic. But now we look at speed versus this one, speed frequency atau speed versus power output. Okay. Normally your speed that dekat x ni, the x-axis start dengan kosong lah. Kosong, ni full load. Ni no load, full load. So but at speed start dengan 1 per unit. Meaning that this one is 1 per unit. Okay, 1 per unit, this one is 1.04. So this is the idealized governor characteristic, 4% droop. Kan drop or droop. Kalau 5% droop, maknanya sama. Tapi dekat sini ialah 5% lah, 1.05. Okay, kalau 6%, 1.06. So kita akan guna segitiga ni banyak lah dalam kita punya analisis. Okay, an important feature of governance system is the mechanism by means which the governor sleeve and hence the mains valve position can be changed. So basically, you can bring this figure up to down lah, bawah ke atas to control. Okay, this is accomplished by the speed changer or speed motor ni lah kat sini. Speed changer ni yang control, yang mana the effect of the adjustment production family is parallel. Dia akan parallel macam ni. So let's say we have nominal speed 1 per unit. This is our nominal speed 50 Hz. And then we have, this is characteristic of the generator lah. Genetic generator tu dia 4% drop, maknanya 1.04. So kita boleh play around with this slope. So governor setting dia boleh play around with this, but this is parallel lah. Boleh buat ke bawah ke atas. So let's say we have this one is full load. So this one your P out, you can measure ataupun you boleh control the power output lah from the based on the speed as well as your punya power output. So this is the effect of speeder gear governor characteristic for P1, P2, P3. Whether P1, P2, P3 should be played around with this slope. Okay. Example ni ada dalam buku saya lah, boleh refer. So saya rasa kita stop kat sini. Kita akan cuba tengok macam mana kita nak guna this characteristics when we have load is enforced in the system. Let's say we have 2 generators. So berapa generator satu kena produce kepada load tersebut. So macam mana kita akan tengok nanti, kita akan guna this figure ataupun this concept of speeder gear ni dalam division of load generators. Okay. So today is just introduction how we control the frequency. So next we will discuss in detail when the load is enforced to the system, how we determine by the characteristic of the generators based on this groups percentage that we can calculate directly by using the simple slope equation to calculate the load division between the generators. Okay, kita start kat sini. Ada soalan? Tak ada Okay, kalau tak ada kita stop, kita jumpa hari Khamis pada waktu yang sama. Okay, that's all for today. Thank you very much. Saya akan upload video ni. So hopefully you can understand what we have to, apa yang telah saya sampaikan lah.
Terima kasih doktor.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih doktor.
Thank you, sir.
Waalaikumsalam. Thank you, doktor.
Sir test sir.
Alright.
Thank you, sir.